Let's welcome Tung, our first speaker.
Okay, all right, so I'm going to talk about this tool I wrote. It's called Jets. It's a Ruby serverless framework. And I guess I'll jump right into it once this starts clicking. Okay, so first, the traditional background slide about who I am and what I do. My name is Tung Nguyen. I run a consultancy company called BullOps. We do mainly focus on AWS software and DevOps work there. The icon's that lightning bolt on the left-hand corner. There's a bunch of other icons up here for some of the tools I've been fortunate and lucky enough to create in the space. It really runs the gamut. It runs from Elastic Beanstalk with the Jack there to even CloudFormation with Lono. And I was recognized, a pretty big honor for me to be recognized as AWS Container Hero in the space recently for I think that tool called UFO. It ships Docker containers onto ECS. But of course, today we're going to talk about Jets, the Ruby Service Framework, because it's a Ruby conference. Okay, so I thought, so this is infrared, so I'm going to have to get used to that. Okay, so last year, November 2018, this is a picture I actually took from AWS reInvent in Las Vegas. I was at front row center, and they announced Ruby support for AWS Lambda. And for a while there were a lot of different languages. There was Go support, Node, Python. There was even C#, but no Ruby support. So that was just something I was kind of praying for a very long time, and it finally happened. I actually screamed out a little bit. I was like, yes, finally. It was like, for me, like an early Christmas present, kind of like the Ruby releases on Christmas. So I was pretty excited about that. And then I thought a good way to actually introduce Jets and serverless is actually cover some fundamentals that I think are important. So I put up this slide right here about showing the AWS compute offerings from EC2 to ECS and then Lambda. So we'll just kind of go from my right, your left, to the other side here. On that end, EC2, those are essential virtual machines. They spin up in 2 or 3 minutes. They're just any machine that you can spin up a server and you can install anything you want on it. It's pretty much self-managed, or you manage it yourself in a self-service. Then you kind of get to the middle there, where it becomes a little more management from AWS. ECS stands for Elastic Container Services. This is a managed service that's offered from AWS that allows you to run Docker containers easily on EC2 instances. Then you kind of go to the left. Then you have AWS Lambda. So with AWS Lambda, you have less to manage. So what is AWS Lambda? Well, people call it serverless. I'm putting in quotes and a smiley face there because I think the name is really funny. In order to be serverless, you have to have a server. So it's a really bad name. It's an oxymoron, kind of. And I thought it's just funny how they named it that, because I think it's just a lot of hype around the name. So what we did, or how I like to define it, is functions as a service. So it's just a way to run functions, and AWS manages the infrastructure for you. Another way of kind of think about that is you run code without managing the servers. So that's the kind of the key benefit with serverless. So let's talk about some key benefits. With AWS Lambda, there's no maintenance. So instead of you patching that OS, applying the security updates, you give it to a team of AWS engineers, probably a couple of hundred, maybe even a couple of thousand, are working on AWS Lambda full time. Then you do not have to manage that. All you do is provide them your code, you give them, and they figure out how to run it. Okay. The other thing about AWS Lambda is it continuously scales. Now, I was pretty impressed when I discovered auto scaling, how you could tune it and like it automatically scales up and down. But this is actually a pretty incredible feat of engineering. This is functions as a service that basically scales up and down continuously based on demand, without you actually having to do anything. That's actually quite interesting. Then the last benefit, I think, is a very interesting one in terms of costs. You pay per request. So with serverless, there's a free tier. If you have an application that runs less than 1 million requests per month, and let's say if you have a staging environment or a development environment, which we all want, we always want a lot of those, guess what? Your staging environment is probably not going to run 1 million requests a month. So you essentially get infinite numbers of development environments for free. Even with EC2, it costs some time, it costs some money to run those servers. With this, there's no cost. However, I wanted to talk about some of the serverless hype. Because there's a lot. I mean, the whole word is kind of hypey, right? So let's talk about what I'm going to call considerations or challenges. So in the serverless world, you're basically on their platform, and you have to kind of your application has to work within the serverless environment. So let's talk about some challenges if you're going to consider using this. Your process, or basically a Lambda function, can go up from anywhere from 128 megabytes of RAM to 3 gigabytes of RAM. Now, in the Ruby world, you have kind of Puma, you have threads, you have unicorns and processes, and how you scale that is you can configure higher numbers of threads, and then you maybe have your server have like 4 gigs of RAM, and then you configure 30 Puma threads, right? But here, you're not scaling a thread. You're not scaling threads. You're scaling the entire server. So if your Ruby process takes more than 3 gigabytes of RAM, you probably got other problems. So I don't think that's actually a big concern. So 3 gigs of RAM for basically a Ruby process should be sufficient. Okay, how about CPU? So CPU can be a bottleneck, but again, the way AWS Lambda works is you are allocated a proportional amount of CPU depending on how much RAM you allocate to your function. And the magic number is around 1.5 gigs of RAM, rumors basically, where you get 2 cores. And for most things, that's plenty unless you're doing maybe like Bitcoin mining. So I don't think CPU is really bottleneck either. Okay, network speed. Sometimes engineers kind of like to blame this. Oh, we must have saturated the network with our application. No, usually it's your application code that's slow. Usually the network application, especially on Amazon services, I mean, I've tested it. One, like very fast internet connection, even on the T3 instance types. And that's supposed to be the slower network card. So usually the network's not going to saturate, so I don't think that's really concerning either. Okay, there is a max timeout. Now, if you have a long-running job and you're doing jobs with serverless tools, 15 minutes is a consideration. You basically save state and then continue the job over. Now, if your web request takes 15 minutes, your user's gone. So you should not have that as a concern either. But code size limit. So I will say that this is actually a valid concern with Ruby particularly, because the gems and binary dependencies, they can take actually up to like a Rails application like 100 megs or so. So you basically have 150 megs left to allocate to your application. So you're out of luck if you're above 250. So I would not suggest anything above 250 because you're out of luck until basically they increase the size, which I think they're going to eventually do. That was not the original limit. The original limit, even like 2 years ago, was 50 megs. Okay, now I want to address something called cold starts. Now this is something that the internets and the webs make a big deal about. Cold starts is basically essentially when you call Lambda function for the very first time, you hit the cold start penalty. That's what it's known as. But essentially, it's the very first request that comes in. Is because it's the first request, that's the first time Lambda has spun up that container essentially. And when they've spun up that container, there's like depending on how much RAM you've allocated to your Lambda functions, it could be anywhere from under a second to like 1 or 2 seconds if you like were really cheap about your RAM allocation. So it could be a second or two from that first request, and then people make a really big deal about that. So what this is supposed to represent is a car with a cold engine, so a cold start. And again, people make a big deal about that, but this kind of reminds me of Rails Russian doll catching. So with the Rails Russian doll catching, you basically have a dynamic cache key with a timestamp address added to it. So every single time you update an article, what happens is that cache key is a new cache key, you get a new cache. That first request is going to be slow, guys, right? But then maybe the other 10,000 requests are going to be pretty fast. And at the end of the day, one request at 10,000 is not at the end of the work, unless you maybe building NASA spaceships. So people make a really big deal about this, but actually don't think it's that big of a deal. But anyway, just to address that, I did not put that engine on fire. That's supposed to represent pre-warming your Lambda functions. It's a horrible picture, so let's do better. So what you can do is you can pre-warm your Lambda functions. Is a pattern that people use in the service world. You basically have a scheduled job that runs repeatedly that calls a Lambda function that fans out to all your other Lambda functions, sends a dummy payload, and basically keeps it warm continuously. Cold starts basically happen about 4 or 5 hours, I found, but it kind of varies, and AWS Lambda is not very specific about the details there. Okay, but that's a workaround there for pre-warming if you really care about that one request out of 10,000, which people still scream on Reddit about a lot. Okay, so I cover AWS Lambda for some essentials there, but there's actually more to serverless than just Lambda. That's maybe what most people have heard of. But there's something called API Gateway. So what is API Gateway? You could think about it as a front door. Users send a request into this front door called API Gateway, and then it can fan out to Lambda functions and return results. So that's a simplified diagram, but this is maybe a more diagram that web developers might connect with a little bit more. Basically, here's users coming into the API Gateway, There could be a RESTful API gateway. There can be WebSocket API gateways also. But this happens to diagram a RESTful API gateway. So with RESTful, you got the basically get posts, put calls, the delete calls, and you have a URL route. And those map to Lambda functions. They return back to API gateway. So that's basically API gateway is kind of routes as a service. Okay, there's even more to serverless that I want to cover in terms of fundamentals. CloudWatch logs. So if you guys, most people have used CloudWatch in the sense of the logs, like centralized logging. But there's also something called CloudWatch schedule events within CloudWatch. And essentially what that is a scheduler. So you can actually schedule work and repeat that. Except this is a managed service again. You don't actually have like a Heroku clock service or Heroku worker tier, because this is all managed by somebody else. I just want to review. We cover a bunch of actually serverless component essentials here. Lambda, which is functions as a service. API gateway, which is routes as a service. CloudWatch, and we're kind of leveraging that as basically scheduling events as a service. So a scheduler as a service. Okay, so with all those components, we can actually combine them all together to build a web API architecture, which maybe Rails developers are more familiar with, or Ruby, Nostra developers. But you can see the request comes in API gateway. It calls out to Lambda functions. It actually calls backend databases that are also serverless. So that's DynamoDB, that's a document-based serverless, NoSQL serverless basically, and there's RDS Aurora serverless too. So Aurora is actually a RDS, Aurora is a RDS variant that allows you to scale up and down your capacity on the fly without you managing it again. And then you can see in the picture diagram there, there's CloudWatch events, basically handles the scheduling of the jobs repeatedly. Okay, so I've talked a lot about basics, but let's actually see serverless code a little bit. I thought a really good way to introduce this, because a lot of questions I kind of get are around just like, so, you know, this framework Jets is cool, but there's a lot of AWS in here. So let's kind of cover some of the essentials. I thought that'd be helpful. So I'm literally going to go through the web browser, and you guys see how easy it actually is. It takes like 5 minutes to create a Lambda function, kind of remove that kind of gap. Okay, so create a function. You can specify Ruby there. You can specify the function name. You hit create. Then this is actually the IDE that you're presented with after you create a function. And I want to point out the handler up there. There's 2 parts to it. There's a Lambda function part, which basically represents the file name. And then there's the second word, which is Lambda handler, which represents the Ruby method within your file. And then that Lambda handler has to take a certain signature, which has 2 keyword arguments, basically event and context. And then that's returning a hash structure with status code and body. So you hit test, and you can actually test everything in your browser. This is like insane. And then you could also see the results in the logs in your browser. All right. And then how do you create API gateway? Let's do it in the browser again. Let's go there, create a REST interface, create a new API, name it, hit create API. Here you can basically create your RESTful routes. You can create the get method with the resources / right now. You hook it up to integration type of Lambda function, because that's what we're going to use. Basically type out the Lambda function hello. It auto-completes in the browser, and then you save it. And then it gives you this nice diagram showing the request visually. A request comes in, it hits the Lambda function, and comes back through integration response back to the user. Okay, CloudWatch logs. So you go click on the rules. Number 1 there is like a side menu bar. And then there's a schedule. You could do fixed rate, or you could do a cron expression. Then you specify a target Lambda function. You click configure details, another page. And then basically you have a show page of your CloudWatch event rule, which is the scheduler, tied and connected to the Lambda function. All right, so I showed you how to do that all in the console, but most normal people don't do that. Congratulations, we completed a crash course of basically all the serverless components you kind of need to know to build an API architecture there, okay? But most people actually don't do the function, because imagine deploying code every single time and updating it, right? So what most people actually do is YML. So I just want to emphasize YML is not code, it's configuration. But this is actually how people are deploying the serverless nowadays. It's just, it makes me sad. It reminds me of Java. In the 1990s, there were a bunch of frameworks that came out, like Hibernate and all those things, Spring and all that. And what happened was, instead of writing Java code, you started writing XML configuration. And your job became like this adventure of like figuring out the exact setting you need to figure out in XML land to like, and you knew it was going to generate Java code someday. And you're just like, please work, right? So this is what we're doing now. We're basically doing YML as code. So yeah. So that's why I wrote Jets. So let's actually see some Jets code now and see what that's all about and everything, because I haven't shown you anything yet. So there's a Jets simple function. This looks just like the Lambda console that I showed you earlier. But really, there's actually not a lot of value here. It's just a regular Lambda function. There's actually a lot of higher level concepts in Jets that makes it a lot easier. So this is actually, I think, the first one that's very interesting. This is a Jets controller. It inherits from an application controller. There's an index method there. There's a show method. Those public methods get translated into Lambda functions. Jets evaluates your code and translates that to Lambda functions, individual Lambda functions. And what it does is it actually provides some helper methods there too, like render JSON. You can render XML, you can render HTML. There's also a params helper that parses out basically the event payload. And you do a puts that goes to centralized logging, CloudWatch for free. Okay, so that's how you actually do it. There's a Jets routes file, and this Jets route file, there's the RESTful routes there, there's the get call, post call, and there's the URLs. Guess what that gets translated to? API gateway resources. It's a perfect mapping. Routes are basically mapping to routes as a service, which is API gateway, so you don't have to manage it. Okay. Then there's Jets jobs, and Jets jobs, there's a rate expression on the dig method there, so we're going to do a hard job, So rate, and then you can also use the keyword cron, and that gets translated to, guess what? CloudWatch event rules. So this is all kind of evaluated and packaged for you and kind of deployed for you so you don't actually have to manage it or build it manually like we kind of discussed earlier. So wanted to review the components real quick. So Ruby methods gets translated as long as they're public into individual Lambda functions. Routes in that routes file, routes.rb gets translated to API gateway resources. Jobs get translated to schedule event rules. Okay, so Jets project structure, it looks like this. App controllers, it might look familiar to some of you guys. Helpers, another familiar concept probably. JavaScript, that's Webpack. So using Webpack to compress access and everything else. Jobs, basically cron jobs or like schedule event jobs. Basically anything that you don't want to block the web request response cycle because you don't want to slow experience for your user. You want the slow jobs to run off that cycle. Models can be active record models or DynamoDB models. Both are supported in the same application. Views in there. There's configurations also. Configurations like environmental specific configurations. DB for migrations, public files, and specs for our spec tests. Okay, so I just want to emphasize this why, Jets again, because YML versus code. That's not that bad, 15 lines of code, but imagine an application that's even small in size, like 10 methods. You're going to duplicate that YML over and over, and so you have a lot of duplication, and it's going to get pretty long versus 6 lines of code there. And then not only that, you have the full expressive power of Ruby, a programming language, versus a configuration language. Okay, so it's a quick demo time. So I'm going to try to do this with one hand. We'll see how this works. Oh, thanks. Okay. So, all right. So what we're going to do is, it's going to be pretty funny. I'm going to go to the quick start and copy and paste. Okay. So quick start. I don't have to install Jets because it's already installed. But I'm going to go basically Jets new demo. And what that's going to do is that's going to generate a new project, a skeleton project with the app folders, the structure, everything you kind of need. It also does a bundle install. That's what it's doing right now. Or I guess it just finished the bundle install. Then it does a Webpacker install for JavaScript assets and everything else that you kind of might need. And this part takes a little time because Node takes a while to do a yarn install. So, but we're going to wait, and then we can see that. And then the next step, let me kind of figure out what the next step is supposed to be. Okay, so I'm going to generate scaffold. But actually, once this is done, it's actually going to spit out a kind of like a guide to exactly show you what to do next. But this is all kind of generate for you, so you don't really have to do much there. I'm using actually HTML mode, which is the default mode, because I think that's what people are probably used to. But there's also job mode if you want to do more lightweight jobs, and then API mode. So now I can follow my own instructions here, cd into demo. And then I could generate the post model right here. So I'm just going to copy this right here. And basically, it's a scaffold. Might be familiar. So a scaffold would generate basically the model, the views, the controller, and all that. And then I don't have to migrate because this is a local database that I have migrated before. But I'm going to copy basically a secrets file with the database credentials into this folder. And then at this point, I'm ready to deploy the code onto serverless. I'm done. So the code is now being packaged, bundled up. The gems are being created in something called basically a Lambda layer. I'm going to start actually exploring the project a little bit while this is deploying. So let's go click around and see what we created here. So there's the post. Let me move that there. And then we'll kind of watch it deploying down there while we click around here. So here's the post controller. familiar actions here. Remember, public methods gets translated to Lambda functions, private methods do not. So that's one way you can kind of like keep your code organized. You can also just put methods in maybe service models or wherever else, or just regular classes. Okay, let's see what else. There's helpers there. So helpers is modules, like what you guys are probably used to. There's the JavaScript folder. There's the models folder. So a couple models were kind of created. Right here, there's the application record. I'm going to start organizing. There is the post model, which inherits from application record. There's application item too, which is actually DynamoDB, because you can run NoSQL at the same time with basically a regular relational database. There's a config folder here where you can have environmental overrides and kind of all that. There's like, I guess, a development production test there. Okay, routes. Yeah, I should actually look at routes. There's a routes file here where it kind of creates a resource. This is like a resource keyword that expands out to the 7 RESTful routes. It's kind of very, hopefully familiar there. But while I was kind of talking buying time, the code deployed. So here, the code is done. And so we are now on serverless. So all the things that I just showed you guys in the other additional slides, this is actually running now on Lambda and serverless. And let's go to post because I generate a scaffold. And there we go. If the internet will cooperate, there we go. We can actually go create a post model here. Post 4, submit. And you just have your basic traditional CRUD there. So that's kind of done. That creates there. I want to show you one more thing before we kind of exit out this demo here. Is basically a Jets server. So Jets server is just going to start a server locally. And then I'm just going to go to this URL that I set up. So you could test locally before you actually deploy to serverless. Some people are like, how do you test on serverless? And they're like, oh, you just deploy a serverless. Like, well, it might be useful to test locally. So that's why Jet server exists. And then you could basically go here and like you do CRUD actions. But this is just kind of running local versus the other one, which is running on actually AWS Lambda, API Gateway and whatnot. I didn't create a job for this demo, but just really for the sake of time. But yeah, here's the local server and here's the remote server. Okay, with that, I'll kind of go back to the slide deck. Thanks, guys. Okay. Okay. So that completes the demo, and so I wanted to review what we just created with 4 commands. We created API gateway, all the routes. We created all those methods for Lambda. I actually created the database for the sake of time. We did not create the job, but this just is easy. You just kind of create it, and then you deploy it, and Jets kind of helps you manage and package that all for you. Okay. Now I want to cover the Jets core resource model. So the Jets, I will decline that. So the Jets core resource model. So that rate keyword there, that's 1 line of code. But internally, what Jets does is it just expands out and calls a resource method. So I want to point out this core resource model in Jets. All paths lead to the core resource model in Jets. All paths leads to that. Understanding that will allow you to actually extend and add on to the DSL. Essentially, that resource method will create AWS resources, in this case, an event rule. And then those properties, you just actually look up something called CloudFormation, and then you could define your own method. So you could find any AWS resources that's basically available on AWS. Okay, and then connect it to the Lambda function right below it. That's a core design aspect of Jets. Okay, so I want to cover a couple use cases really quickly. Event-driven security auto remediation. So what this is let's say you have like a policy on your office that says you shouldn't open up port 22, but you know admins are opening up anyways. So what you can do is you can actually have a rule event that's connected to the Lambda function that fires whenever security group changes are made. And you evaluate whether or not port 22 was open world, and then close it. So that guy who opened up, he'll probably like, he'll like, why didn't it open? Because it just automatically got closed. And then you can actually send yourself a message to notifying who opened it. Okay, so what does code for that look like is you'll see the same pattern. The AWS resource is above it, the Lambda method, and then that generates YML eventually. Okay, another kind of use case here is serverless cron. So like with cron jobs, you usually have like a cron box somewhere that you have to install something and like a pet server. But with serverless, you don't actually have to manage that. You don't have to even have a clock process on Heroku or a worker process on Heroku. This is all managed for you. So you could basically have a CloudWatch event rule called Lambda function. This happens to back up Route 53 records because apparently not a lot of people do this. It's kind of useful to have in case you ever make DNS changes and don't know what you changed. All right, so this is how that works. There's the code. It looks kind of familiar there, or snippets of it. It generates YML once again. Okay? Polymorphic support. So before introducing the next use case, I want to cover polymorphic support real quick. So when I was creating jets, I was like, oh, man, there's not a lot of Ruby examples out there. And I ran into a lot of Python and Node examples for a project I was working on. I was like, it would be faster if I just added polymorphic support, or like basically I translated like, it was about 20 or 30 methods to Ruby. I was like, I think I'll just use that time and energy at polymorphic support. So what that is Jets allows you to glue other languages together, including Python and Node. So how does that look like? You actually have this convention where you go Python index, and then you write the Python method right there in a folder with index.py, and that is Python code. That's not Ruby code there. But the Ruby code glues it together, because Ruby is such a great gluing kind of language. There's Node too. There's how you do Node, same idea. There's the Node keyword, and then there's a show.js file, so you're writing Node there. And what I use this for was something called basically compliance. So some companies, large, are really into compliance, and they have auditors come in, and you have to prove to the auditors that your account is compliant, your AWS account. So AWS config rules, what it does is basically it scans your AWS account continuously and tells you whether or not it's compliant, and it eventually produces like a table like this: compliant, 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 compliant. Then you can show this to the auditor and like prove them that you're not only compliant, you're compliant on a real-time basis, because AWS changes too fast underneath the hood. So you could actually continuously run compliance rules. And what does that code look like? It looks kind of like this, basically Ruby code once again. Okay, this was a fun one, Internet of Things. So IoT, I had a fun time putting this slide together because I didn't know there's so many things that connect to the internet now. There's, I guess your house, a car, thermometer, there's a tea kettle. You could, for some reason, send tea kettle data to the internet. I don't know why, but you can. And so there's probably some reason, and then eventually it's the same thing. It hits a Lambda function. And that Lambda function, you could run custom logic on that. What does that kind of look like? Here's a thermostat job, and there's basically something called IoT event, and that runs a IoT action, or a kind of SQL kind of rule there. And then what happens is when that topic is triggered, it's going to call that Lambda function. Okay? And then I'm just putting the kind of event into CloudWatch logs for debugging. Okay, and that's what the code that I produce is, YML. We're not writing YML, we're writing code, right? So much more powerful and so much more clean. Okay, so a couple things about Jet's features. So pre-warming support I mentioned earlier. Again, I don't think it's the actually biggest thing in the world, but it's there and available. It's just a couple of configuration files, and then you can tune it to pre-warm it more frequently or higher concurrency and all that kind of stuff through a simple configuration file. A local server, because local development and testing is very useful, I found, before deploying. Apparently not everybody in service world thinks this, but it's very useful, I found. There's Jet's call. This is another way to actually test locally and remotely, basically calling either a local method or a remote Lambda function. There's a third way to test locally, called a Jet's console, which just spins up IRB shell and then loads the environment in. So then you could like, go mess around things there and kind of learn your application. Database support, it supports basically any relational database that Active Record supports. So that's like MySQL, Postgres, and whatnot. And also DynamoDB through its own adapter right now. But yeah, okay. So let's see what else. Function properties. I didn't cover this much for the sake of time, but essentially functions can be configured properties like memory, how much memory a function has, environmental variables, what the timeout is. And you can actually configure this through all with Ruby and DSL. So it's pretty cool. IMA policies. What that is this is how you handle permissions to AWS resources. So let's say you want your Lambda function or your method to have access to S3. So this is where you would define that. You do it through it once again DSL. Okay, polymorphic support. I covered that in the other slides, but it's there and available too. And I just want to show you guys these examples. These are examples on this GitHub repository. It's all up there, and a bunch of different ways to kind of use this framework. Either as a web framework, API framework, or a glue framework. And that's it. Thanks, guys.
Thank you. I guess we have time just for one question, Tung, so just raise your hand. Let's take the closest one.
Sure, questions?
But you have chance to ask questions afterwards, and you get the cards, so you get the cards.
Yes, I'll be around all day, so please come
just
up
give
and
someone
ask questions.
Yeah, let's go.
Okay, cool. So I'm here. Okay, thank you for pitch. That's amazing because it's nice news that we can run Ruby natively on Amazon, because 1 year ago you need to write Node.js wrapper for that, so that's really amazing. And I have one question, maybe it's a little bit stupid. Do you have any big production projects on Lambda which use your framework Jets? Because usually guys use Lambda for some small calculations, or for example for testing, for loading. And if you have, how much money do you spend for that, for example, for user? Because you have logs, you have, database and other stuff.
Sure. So I don't think I have to repeat the question, because here's our mic. Okay. So production use cases. There are some companies out there I know are using it. They're mainly kind of small startups. I mean, I literally created this for fun as a labor of love, part-time for the last year or so. So I don't think too many companies, but I know a couple of startups. I've been meaning to put together basically quotes from these people who've been emailing me asking things and all that. But I'm fairly certain a couple of people are using production already. I'm not exactly sure how large, to be honest. Again, it's kind of small project right now, which is good in a lot of ways, actually. And your other question was?
What about costs? How much money?
Oh, cost. Yeah, I have a really good answer for that one. So there's another site in the service world called A Cloud Guru, and they they make learning material for people, like online courses and all that kind of stuff. And it was a joke for them for a long time, because they ran their own not their own framework, but another framework, and they ran their company for 6 months, and they paid nothing.
Nice.
So yeah, it's relatively inexpensive. However, if you're going on a really large scale, then some people have shown calculations where it starts getting more expensive. But this is where it's kind of interesting with Jets. It's actually rack compatible. So you could actually run it on ECS or EC2 if you wanted to, for whatever reason.
Makes sense. Thank you.
Yeah.
All right. Thank you again, Tung, for your talk. Let's give applause.